My name is Rob Schofield. I work in the user interface department at Wolfram, and I am going to talk today about asset management, what assets are, and what are some of the new things we are using assets for in the Wolfram app. So, assets in general, I'm going to talk about a new function in Wolfram version 14.2 called language switched, how we use these technologies to implement the localization of our Wolfram app. In the past, we used a mechanism we called text resources, and going forward, we are using the asset system to do this. And then I'm going to talk briefly about how you can use assets to do localization in your paclets. So first of all, assets were an experimental feature introduced at the technology conference in 2023, and they allowed you to store and associate arbitrary data and expressions in a notebook. So we have this function asset find, and if we asset find all, we'll see that this particular notebook has 0 assets associated with it. So we can add an asset named test asset, whose value is just random real. And then we can then query the value of that asset. And since this is, it holds its argument, it evaluates random real fresh every time we do this here. And so when we now find all assets, we see that we have an asset associated with this notebook. And so if I save this notebook, I can look at the actual file here and see that there's a notebook assets element. It has an asset named test asset 1 and has some data. So then if we no longer want an asset, we can remove it. And once we do that, we'll see that there's no more assets associated with this notebook. And again, if I save the notebook, we'll see that there are no more notebook assets in this file. Okay, so previously, associating assets with a notebook was kind of the only way to use these things. But new in version 14.2, we can now have assets that are kind of global rather than specific to a notebook. And one of the ways that we're using this is that we have reworked our localization schemes using this method. So now when we want to asset find, we can give it an optional namespace where to look. So if we do this and we look in the Wolfram/front end namespace, we'll see that there's 446 assets. We can query one of them. In this case, an asset named tooltip cut. And we'll see we get an asset object and we can get an expression, which is just a string whose contents are the word cut. So in addition to the assets that we're shipping with the system, it's also possible to create assets of your own. So I've created this asset namespace called my test. We'll see that I've got 5 assets here. I can get their value of each of these. And they don't have to just be text. They can be any expression. In this case, it's a graphics expression. And I'll give you, we'll look at how this is done in just a little bit here. So the next thing I want to mention is this new function, language switched. This is how we do our localization. And what this does is it's a function, takes 2 arguments. The first argument is just the default non-localized value. That's the value that gets used when none of the localizations match the current environment. And then you have an association with key value pairs. The keys are just names of different localizations, and then the values to use for those localizations. So if we look at this specific example right here, we'll see we have a default value, which is the English text show all. And then when we're running in the language is Chinese simplified, we see we get this value. When we're running in Spanish, we get this value. One important thing to note is that this doesn't change upon evaluation in the kernel. And the reason for that is that this only makes sense when used in the asset environment in the front end. The front end knows, kind of what language and also what platform you're running on, and it makes the right decision about which of these values to use. So we specify different localizations. Here's another example here. This goes through the resource asset system, and so it resolves to the default value, the English text here recently used. If I were running in a different language, I would have gotten a different value here. So the system automatically chooses the most appropriate value. So here we're switching based on platform. And instead of getting the default value of Alt +1, I'm running on a Macintosh, so I get the value of Command +1. Language switched doesn't have to be used at the top level of an asset value. It can be nested arbitrarily deep. So here's an example of that, where we have a bunch of common values that are used for all of the localizations. And then just this part right here is used. It differs depending on the localization. So we can get the resource value and kind of dig into it a little bit and get the part that's just different this way. So we can localize based on language. And here are some of the languages we support. We can localize based on platform. And this is the same example I showed earlier, where the Macintosh version is different than the version on Windows or on Linux. Or in some cases, we can localize based on both language and platform. And so here, the default English value is Control-C to copy coordinates, but I'm running on an English system on a Macintosh, so I get Command-C to copy coordinates. The values can be arbitrary expressions. They're usually strings, but not always. So here's an example of one of our built-in asset values whose value is a list. Okay, so let's talk about how we're using this to do localization. So the Wolfram app is localized into a handful of different languages. So we run in English here, but the same UI in the app can be used this is what it looks like when running in Spanish, or for example, in Japanese. So we support English, Spanish, Japanese, also Chinese Simplified, Chinese Traditional, and French. Those are fully localized. And then we have partial localizations, bits and pieces here and there for German, Greek, Italian, Korean, Lithuanian, Polish, Portuguese, Russian, Ukrainian, Vietnamese. These are just the ones that I found looking through the resource files. So we also localize based on platforms. We run on Linux. And so all the UI appears on Linux or on Mac OS and on Windows. And in most cases, we do the same things on these platforms, but there are some cases where we need to do different things. So the old way we did this with text resource files. These are files that shipped in the installation directory of the app, in a subdirectory, system files, front-end text resources, and there's just a handful of .tr files. And when you want to access these localized resources, you use this function front-end resource. And in this case, there's a resource named month names, and then here's the value of that. So this had a number of limitations. So first of all, the text resource files were not Wolfram language syntax. They're some different funky syntax, and there's not a good way to read them outside of the system. And the system wasn't extensible in any way. The resources that we shipped with the product are the only resources that ever existed. You couldn't add more to them. Localized resources often lived in separate files from the default resources. So all these different files need to be kept in sync. There's a Spanish version of a file, a Japanese version, a Chinese version, etc. They all need to have the same values or stuff would all need to have the same resources defined or stuff would break. So when we add resources to one, we needed to add them to all. If a resource only needed to be partially localized, like one of the examples I showed earlier, where many of the values are the same, but part of it was different. Using the old system, we had to duplicate all of the parts, even the parts that didn't change. Every resource had to have a unique name. There were no namespaces that could be used, so there's always a possibility of colliding names. And then the text resource files that we used were ASCII encoded, which meant that if you're typing Japanese, for example, you couldn't just type Japanese text directly into the file. You had to type it somewhere else and then convert it into ASCII values, which was kind of a pain. So going forward, we're using assets, and this system is working a lot better for us. So in the same way, inside the installation directory that ships with the product, system files, front-end assets, we have Wolfram Language files. And here's a few examples of those. And just like the front-end resource function that we used to use, we can now use something like expression asset. We can use these asset functions, and we can give it the namespace, Wolfram front-end, the asset name, and then we can get its value. So this is the same asset I accessed earlier, just using a different way of doing it. So assets are working better for us because they are Wolfram language syntax files. The system is extensible. We can add new assets to it. Localized assets live in the same file as the non-localized default version. No more separate files to keep in sync. We only have to localize the part which is different. We don't need to duplicate entireties of assets. We can have different namespaces, so to reduce the chance of colliding names. And the asset files are UTF-8 encoded, which means that if you're typing in Japanese, for example, you can type Japanese text directly into the file and save it, and it's ready to go. So let's take a closer look at these improvements. So we had the old text resource format, which is a little bit funky. We have here, we have 2 different resources in 4 different languages here. And then when we combine this into the new format, it looks more like this. We just have one definition for each of the resources. And then we switch depending on what language is being used. So being Wolfram language format, it's easy to read these asset files in using kernel code. We can automate things. We can run tests. We can transform the data programmatically. And we have done this internally. We have tools. We can kind of transform things like the language switch expressions. We can nest them more deeply or more shallowly. We can scan the asset files for certain types of common errors, like if we thought that we had all the languages present, but it was missing a language, for example. And here's just a quick example of a transformation that we can do. So here's 2 different expressions, which is a list of 3 values in 2 different languages, and you can write it all the values together, as in this case, or you can write it each of the values with their own translations kind of separately. And you see that the 2 unevaluated versions are different expressions, but once we resolve the language switched component, we get the same value out of it. So we can do those transformations programmatically using this sort of scheme. So it's extensible. The assets that you use don't need to be built into the product when the product ships. They can be loaded from a paclet. Each paclet can have its own assets directory containing Wolfram language files that define assets. And so here's an example of from my test example, there's an asset file, which is just an association containing key value pairs. The keys are the names of the assets, and the values are the values. So there's 3 assets defined here, and then we can get the value of one of them. And if we see that this is B is language switched, depending on the platform, and then when I get its value, I get the Macintosh version, since I'm running on a Mac. There are cases where you can just show the, and I'll real quickly show, here's the asset file with the 3 different assets defined. So you can also have a file which just contains an arbitrary expression that's not an association of key value pairs. In that case, the file name is used as the name of the asset, and the contents of the file in their entirety are used. So we can ask for asset2, and it will just get the contents of asset2.wl. We can also use binary WXF files, which you can see here, there's some binary stuff at the beginning of this. And then when that is read in, it's an association of key value pairs. And so when we get the value of asset C, this is asset C. All right, so we can put different localizations in the same file. So if we look at just one file in the old system called locale.tr, we'll see that we have different versions for different languages: Chinese, Japanese, and then the default English. And so we'll see that here's the English version of the file, just the start of it. Here's the start of the Chinese version, Chinese simplified version. And so these things need to be kept in sync. With the new system, we do this differently. We have it all in one file. We just have one definition for the date format, and we use language switched to switch on the language. So it's much easier to keep things in sync using this new system. So duplication. We don't have to duplicate parts of the resources that don't actually change. So here's an example where we have a bunch of values that are the same, and then one little bit of text which is different. So that's the English version. Here's the Japanese version. Again, these values are the same. And then just this little bit is localized to Japanese. So with the new system, we have something that looks more like this. We just keep all the values. And then the part that's localized gets this language switched statement here. Namespaces. So previously we had one global namespace. You asked for one resource, and it has a value associated with it. With assets, we can specify what namespace we want to use when looking up a localized resource. So that same date format resource, we can ask for it in the Wolfram/frontend namespace and get the same value. But my test also has a resource named date format that has a different value. So I can ask for the my test version and get different values. So we can avoid naming conflicts using namespaces like this. So UTF-8 encoding. So text resource files are encoded in ASCII, which made it difficult to type in certain languages. Asset files are UTF-8 and can be typed in directly. So the old version of tooltip.tr for Japanese had text that looked like this, which is not Japanese. This is an ASCII representation that gets converted to the Japanese text. But when we're using UTF-8, we can just type in a text editor. We can type these values directly and they show up, and it's just easier to work with. So those are the benefits. Let's look at how to localize a paclet that you might be working on. So creating a paclet is not in the scope of this session. I think there are other ways to find out about that. So I'm going to start out with just a very simple paclet here. Contains, some pacletinfo.wl, which if you've done stuff with paclets might look familiar to you. We've got a front end and a kernel directory, some documentation. So new is this assets directory. And we have a file in there, tooltip.wl, which is, has our association. It just has one key and one value. So we can install this. Once we do that, and all right, take two. All right, once we install this paclet, we can verify that it was added to our asset path. This is just a piece of temporary code because this feature isn't fully finished yet. But once we do that, we can ask for all of the assets that are in my test assets paclet. Okay, and so we have one, and its name is template box tooltips. So we can ask for the value of that asset. Now, this happens to be an asset that exists also in the Wolfram front end namespace. So we can get that version, and you see that these values here are different, despite the fact that the asset name is the same. So, now that I look at this, I'm seeing that these 2 exclamation points aren't quite enough to really underscore what I'm going for here. So I'm going to change it to 5 exclamation points. I'm going to save this file. I'm going to rezip this paclet file, change the name from zip to paclet. All right, so I've got a new version of this paclet. I'm going to now install this new version of the paclet. Okay, got that installed. Again, temporary hack that won't be necessary once this is fully finished. And when I ask for the asset value now, you'll see I get the 5 exclamation point version of the value there. So packlets can have a front-end assets directory. We can include assets that are in this sort of format here, where we define an association of key value pairs, and then we can access them using a namespace that is specific to our paclet. Or if all you want is to access the built-in version of an asset, you can get it from the Wolfram frontend namespace. All right, so that is that portion of the presentation. Checking in, it looks like I don't see any questions here. All right. I will get this presentation notebook uploaded somewhere onto the conference website so that you can come back to it later if you'd like. And then if I made a paclet with assets, which Wolfram language versions will support it. So a lot of this stuff is new in 14.2. So the assets will be usable from 14.2. If you have a paclet that is going to be used with earlier versions as well, you can either, if you were using text resources before, the text resources will continue to work in the older versions. So it might be possible to have both an asset version and a text resource version in the same paclet, and the assets will be used in 14.2 and the text resources will be used earlier. If you're not using text resources, if you're using something else, then for older versions, keep on using what you're currently using. And once you're no longer supporting those older versions, you can get rid of the old system and just use assets themselves. Okay. Other questions? What other properties of assets are there? There's that. Um, I don't, off the top of my head, know what the other values are. It's anything that can be applied to an asset object, which I don't have the full list off the top of my head. Sorry about that. There are things like there are other bits of metadata that are stored in an asset. So when I um, added this asset here and then saved the file, things like MIME type, creation date, modification date, those are the sorts of properties that you can get from assets. Um, any special handling of FE box content in asset files we should know about? I don't think so. No. So if we look at this example, this is just a graphics expression and that came in directly. The expression that is there in the file is the expression that you're going to get when you get the expression asset. So if your expression asset is a box, then you can do whatever you want with those boxes. You can put them into a cell, you can further manipulate them. So generally, no, there's nothing special you need to do about box content. We are using box content in many of our assets. So it's definitely possible. Is there a cross-platform way to set up custom keyboard shortcuts? So the keyboard shortcuts are read from menu setup.tr. That is a file that hasn't been updated yet in 14.2. So there's nothing different about that now in 14.2 than there was prior to that. So at the moment, you still have to change menu setup.tr, or there's another file, key event translations.tr. And unfortunately, doing so has all the drawbacks that I mentioned of working with text resource files. If you change one of those, you have to make sure all of the values from that file are included with the new copy of the file that you're working on. So this is something that should hopefully be better, maybe at some point in the future, once we get these things onto the asset system, but they're not there now for 14.2. All right, okay, so properties. There we go. Thank you, Ian. Here's a list of the properties that you can get for an asset. All right. It looks like that's all of the comments we have for now. Thank you all very much. And there will be a general front-end Q&A session later on, I believe it's this afternoon, where I will be, and John will be, and Jason and Ian and other people, where we can answer more questions of this type. So if you think of something between now and then, you can come to the front-end Q&A session this afternoon. Great. Well, thank you very much.